Hey guys, so welcome to the BDAA workshop for Numpy and Panda Python libraries. Um, these two libraries are extremely important in data scientists, data analysts, anybody who has to deal with data. These two libraries are considered essential, and you can look it up yourself. Best tools for a data scientist, best tools for data analyst. Um, 9 times out of 10, Pandas and NumPy will be in your top five. So cannot stress enough how important it really is. So first, we're just gonna go over what Pandas and NumPy really are. Just give you a brief, very, very brief overview of what it is, and then we'll go from there. So let me just. So intro to Pandas and NumPy. What is pandas? The term pandas itself is derived from an econometrics term, panel data. Uh, right here is the pandas logo, really cool. And pandas is obviously used to analyze data. It's an open source library, and it's free to use. It provides functionality that would be otherwise difficult to implement, meaning that there's things that pandas does that you could do without pandas, but it would be increasingly difficult and would take up a lot of your time. What is NumPy? NumPy is short for numerical Python. It is also open source and free to use, and it's used to create and work with arrays. So you may ask yourself, why use NumPy if Python already has its own built-in list? The list object is not nearly as fast as the NumPy array object, and for that exact reason, we tend to use NumPy arrays. This is some of Pandas functionality, things like searching, indexing, manipulating the data, like changing certain attributes of the data. Anything you could really do with like SQL, I guess, things like that in a way, with some additional features, and also it's missing some features that you can't do in SQL, obviously. Um, Things like updating, deleting, and altering data frames. A data frame is essentially a pandas object. The pandas object is known as a data frame, and this is like the container of all the data that you're going to be putting in. Things that you could do also include imputation, like replacing missing data, sorting, aggregating, like doing sum functions, things like that. And truthfully, the possibilities are endless. What we're gonna learn today is just really the basics of pandas. You will definitely learn everything you need to know about pandas, but there's just so much to pandas that um, like you really could investigate on your own. NumPy functionality, creating arrays, math operations on these arrays, and statistics on these arrays. All right, time for the demo. So before that, let me just share with you how you could install pandas and NumPy. So what you're gonna type in is pip install, and you're just gonna type NumPy. I already have it, so it's just gonna say that that the requirement's already satisfied. But for you, it may say something different if you don't have it already. And then pip install pandas. All right, cool. So we got everything already downloaded. It may be different for you, but who knows? If you have the Anaconda Navigator like me, it's already downloaded. Even so, like if you never downloaded it, but you have the Anaconda Navigator, and it says that requirement's already satisfied, that's why. And quickly, I'm just want to show you the data itself. Oops. It's in a CSV file. So this is how it looks, the CSV file. Obviously CSV file is just comma separated, but like this is how it is if it was to be all actually organized. Obviously you could see some values are missing right here because these guys probably were like on 10-day contracts, or they got they ended the season in free agency, so they didn't really belong to the team and things like that. All right, so forget about that. And now let's start actually doing the workshop. So first thing you're gonna do is import the pandas library. So we're gonna import pandas as PD. PD obviously short for pandas, and we're gonna make a data frame. So this is a data frame. We're just gonna make it stand for df. We're gonna set df.read. df is gonna be equal to df.read. Equal to pd.read underscore CSV open parentheses open quote, and you're just gonna type in the name of the file. Make sure it's under the same directory as wherever if you're using Jupyter Notebook, make sure it's under the same directory as wherever this Jupyter Notebook file is. And that goes with whatever ID you're using. Just make sure it's under the same directory. All right, so now we created a data frame, right, by using this short, simple code. By the way, this CSV file I'm going to be sending to you guys. So we click DF, and look at that. All the data is laid out very nicely for us because it's laid like this way because it does that automatically for you on Jupyter Notebook. If you're using another IDE, this is how it may look. It's all the same. It really is still like completely fine that way, but obviously it looks a lot better this way and it's easier to read. So that's our data frame. Our data frame is labeled by DF, so we're gonna be using that a lot. So remember that. So you can see we got like the name, height, weight, all of these attributes like the free throw percentage, field goal percentage, and you can see there's 521 rows by 17 columns. Over here shows the 3 dotted lines to show that obviously not all the data is in front of us. This is just like a summary. So say now that we got the data frame loaded in, we want to see like the first 10 attributes and the first 10 records. So simply all we have to do is type data frame dot head meaning from like your top kind of, and then however many values you want. Say we want 10, so we put in 10 and we got exactly that. We got 10 values with everything included, every column included, the first 10 players. Over here you can see 0 through 9. These are the indexes. This indexing is given to us by Pandas as soon as we load it up into the data frame. So if you want to say, what if you want to see just the column names? Then you type in df.columns. You can clearly see it's a list inside like this type of tuple, I guess, object. So in order to see it in list form, you just list.df column, and you can see all of the attributes like they're in a list. Very nice. So say if you want only like a certain column, like say we only want like their names, or we could just do df open square bracket like you would be slicing through a list, and you just type in the name, the title of like the column. So say we only want name, that's exactly what we got, just the name. Say if you want more than one column, but you don't want all, you could just type in, you make a nested list, so 1 list, 2 lists, and then you go name, or whatever columns you want. So say I want the name, and you separate them by commas. So name, I want the height, and I want their team. Clearly you could see that it's exactly that, the name, height, and the team, just like it did from before. But instead it's only giving us the name, height, and team. It's the same exact people in the same exact order, but instead we don't want those other columns, so we cut them off. And say now you want like the name, height, and team, or just a name or anything. You just say you want a specific column and you want a specific amount of records. So now here what you do is you basically just do the same thing as you would as if you were iterating through a list. you just type in whatever values you want. So say we want the first 10, we're gonna do 0 through 10. Obviously, 0 to 10 by index is 11 values, but this second value right here, just like a regular list, is up to but not including. So we got the 0 through 9 indexes, meaning that we got all 10 of the records that we wanted. All right, so pretty cool. Now say if you want like a specific row for whatever reason, then you do df.iloc. I believe that's integer location, or it could be index location. I'm not too sure about that. But so you do df.iloc and whatever number you want. So say we want the first one, we get the same first guy, Alex Abrinas. As you can see, that's the 0th index. Say we want maybe the 250th player. We got Josh Jackson on the Suns. You clearly cannot see that here because this is just a summary, but this goes to show that the data is still there. We're at 250 and we got Josh Jackson. So yeah, that's pretty cool. Just like if you want certain rows and things like that. You could do, excuse me, sorry. With the I location, you could also do integer slicing. So say we want 250 to 256. So we get the what's it called? All these values over here from 250 to 255. Remember, it's 255 because this second value here is up to but not including. But see, we got these 6 players over here with all their attributes just by using the df.ilocation. Say with this iLocation, we want maybe the 100 to 111 player, right? And 100 to 110th player. And we got all these guys. That's super cool. But we want the 100 to 110th index, but we want it without we don't want all these columns like before. So how would you do that? Thing is, the iLocation function, it takes more than one parameter. So the first parameter is clearly the indexes of the players that you want, right? So the 100th index to the 110th index. The second argument is the columns that you want. So say you want 0 through 5 columns. We're gonna get the 0, 1, 2, 3, 0, 1, 2, 3, and 4 columns, because of course this is up to but not including. So we got the 0th, the 1st, the 2nd, the 3rd, and the 4th row. The 4th column. And these obviously correspond to name, height, weight, team, and age. Say we wanted the up to 7. Then we got more. We got name, height, weight, team, age, salary, and points now. So if you want to just look up a certain range, you use iLocate df. Whatever the name of your data frame is, .iLocation, with square brackets of the range of rows you want, and the second argument is for if you want to choose a range of column titles as well. So now say I want a certain value, say I want to find LeBron James's I want to find LeBron James is records, like his age, salary, whatever, things like that. Once again, remember this is 2018, 2019, by the way. So this is obviously not current. But say we want to find obviously if we look at this data frame that we have, when it's summarized, we can't see LeBron James. We don't know where he's at. We could use iLocation, but that would mean that we would have to keep guessing the index that he's at. So instead, to make this easier, you could just use, instead of the iLocation, integer location, use just df.location, LOC. And then you open the brackets and you type the name of your data frame again, df, and you give the column that you want to access with a list within a list. So first, this kind of gets a little bit complicated in how many lists there are. So first, there's df.loc. So for that loc, df.loc, we open up brackets for that function. And now we do, we access our data frame again, and then we open another bracket up to specify what column we want to access. Because obviously the name we're looking for LeBron James by his name. So if we search up, that if we just search it up, the computer doesn't know what column we're searching for. And obviously if you put the wrong column, there's not going to be a LeBron James in wait. So you got to do df.location, open bracket, and then df again, the name of the data frame, another open bracket, and then you specify the name of the column. So we want name. Then we get out of that first bracket, because we already specified. So right here, this essentially just enters into memory of the data frame of the name. So so we're inside the data frame name column, and then we get out of there and we set it equal to whatever attribute we're looking for. So say we're looking for LeBron James. You do just that. You close the square bracket and look at what we get. We get everything we want for LeBron James, and there's only one LeBron James in the league. So obviously there's only one record. Say if you want the age, and we want to find, let's say, like the young guys. So we find like a 20-year-old. And you can see that there's this many 20-year-olds in the NBA in 2018, 2019. Pretty cool that these young guys could be playing in such a difficult league at such a young age. So now, say we want to search like with an or operator. Like we want LeBron James, or we want Carmelo Anthony. These are just like my favorite players. So like some of my favorite players. So that's why I'm just like choosing these names. But obviously it could be any name that you want. So we do the same thing. We do df.location. Do the same exact thing of entering the data inside this df.location function. We do df of name equal to LeBron James. And then so clearly you could see in this one, after the location, I opened up a bracket just like we did before, right? But instead, I also put this whole entire record inside parentheses. So I accessed the data frame name column, and I'm looking for LeBron James. So now you put that in parentheses because that's the first record we want. And then we separate it with the or operator. If you didn't know, this is the or operator right here, like that long line looking thing. And then you include your next query, essentially. So once again, with the same exact format. So df of name, because we're looking inside the name column of the data frame. We're going to set it equal to Carmelo Anthony. And now you can see that we got Carmelo Anthony and LeBron James. And Carmelo was all the way like the 17th index, and LeBron was at the 253rd index. There was no situation where these two guys would be right next to each other. So when you using this location function is extremely important and useful when you want to specify certain people, certain records, and things like that. So now say we want to find players that average more than 20 points. Averaging more than 20 points is obviously extremely hard in the league. Very few amount of people do it, but obviously it's doable, and it's very successful of them that they could perform at such a high level in the NBA. So say we want to find all of those players that average more than 20. We're going to do the same thing. We're going to go use the location function, and instead we're going to access the points column. And rather than using the equals operator, we're going to set points more than equal to 20. And now we got all of these players going from 6th to 505th index of all these guys that score more than 20 points. Clearly, you could look at this row and every single one of these guys scores more than 20 points. Or exactly 20, like Lou Williams. So yeah, so what we could consider this is consider these as good players, you know, because they average more than 20 points. These are all names that every NBA watcher has heard of because these are all very good players. So now, say points doesn't really tell like the whole story. You know that points doesn't tell the whole story because somebody that shoots more is probably going to end up making more shots, right? So how about we look at the points, but we also want to see how accurate they are. So now we got all these guys that get 20 points, but like some of these guys' field goal percentage isn't too great. Like over here, I mean, I'm seeing some pretty good ones. But let's say like right over here, like 42%. Russell Westbrook, he shoots 42%, 42.8%. Say we want guys that only shoot like that score 20 points and shoot above 50%. So to do this, we do the same function again, the LOC function. So df.loc df, and now we're gonna check their points scored. So we're gonna do points obviously, and we're gonna do points more than equal to 20 points, which is obviously a very great achievement. So we put that in parentheses. And now instead of using the OR operator, we're going to use the AND operator because we want more than equal 20 points and also has a field goal percentage. Let me just make sure that's exactly. Yep, that's exactly as formatted. So now we're entering DF of field goal percentage. And we're going to make sure that is more than 0.45. And we enter that. And now you could see that look, this list was a lot longer than this list because once it gets to shooting 45% and over, that's when you find like the real good efficient players. You see those Kevin Durant's, players like that average 26 points, but yet on top of this 26 points still shoots an amazing 52%. Like that is the mark of a really good player when they could score a lot of points and yet make a lot of them rather than missing a lot of them. Because to score a lot of points, you're gonna need to shoot a lot. But how much does your points really matter when you're not shooting efficiently? All right, and now say we want to find a player that averages a triple double. A triple double is when you average. Let me write this down. Triple double is when you average more than, like, you have more than 10. So like the double part comes for the 10, right? Double meaning 2 digits. So you average 10 plus in 3 different categories. So for example, you average more than 10 in points, assists, and rebounds, right? So say we want to find a player that averaged a triple double in points, rebounds, and assists. So let's do that. So first we're gonna do df. So we're gonna do df.loc, enter into the df data frame, and we want the points first, and we want the points column to be more than 20 points, and we use an AND operator because we want all these conditions to be true, and we want df, we want the assists to be more than 10. Actually, we're going to do more than equal to, by the way, because remember, it's triple double starts with these. So we're going to do points more than equal to 10, assists more than equal to 10, and finally, rebounds more than equal to 10. And we click enter, and lo and behold, there's only one player to average a triple-double, and it's Russell Westbrook. He averaged 22.9 points, 10.7 assists, and 11.1 rebounds. 3 stats, all with more than 2 digits, triple-double right there. He's the only player to do that. So, say now we want like just a quick description of the data. There's this really neat function called dot describe, and you do dot describe, and you could find like these, like the count, the mean, the stats, the standard deviation, and all that of each attribute. So of each numerical attribute. So you see the average height in the NBA is 70. We'll say 79 inches. So if we were to convert that, 70 divided by 12, the average NBA player is about 6.5 feet. So obviously they're very tall people. The average age is around 25.9. We could say 26. The average player only averages 8.7 points. That's why I said averaging 20 points is a huge mark. And yeah, these are the rest of the stats. The average field goal percentage is 44.5%. I'm just gonna plug my iPad in real quick. Sorry about that. So yeah, the dot describe function is extremely useful, and it's very simple. So obviously, I'm sure that's gonna come in handy for you one time, at least one time. All right. And now, let's get to like the doing things with the data more than looking up rather than looking up data. Let's start actually doing stuff to it. So say we want to sort the values. As you can see, it's already sorted the data, I believe, by last name. Yeah, so you see Abrinas, AC, Adams, going all the way down to Zubac. So say rather than sorting it by last name, we want it to sort by the height. We want to see the shortest players first. So we want to do df.sort underscore values, and then open parenthesis, and then just a column that we want to sort it by. So we want to sort it by height. And you can see right here, the shortest player in the league, Isaiah Thomas, is 5 feet 9 inches tall. Now say we want the tallest players, right? So by default, when you use a sort values function, it's going to be in ascending order, meaning shortest to largest. But to change this, you could, so like say we want height, and then we add the argument right here, ascending, and true means that it's ascending, obviously, and false would mean it's descending. So if you do df.start values on height, and we make ascending to false, we get the tallest players first. Tallest player is 87 inches tall, so that's well over 7 feet. Now say you want to sort on more than just one attribute. So let's say we want to sort values on 2 different parameters, and we want it to do on, let's say, age. So what you do, you do like the open parentheses after sort values like normal. And since now there's gonna be 2 arguments, you're gonna do a list inside here, and inside this list is where you're gonna put the columns. So we want age, and we want points, and we want ascending equal to false, meaning that we're gonna find the oldest players, which 42 years old, very old for a league, Oldest players and most point and oldest players with the most points. So first by age, then by points. So the oldest player averaged 7.4 points. Clearly you could see here there's two 38s right here in a row. So first by age, then by points. So now he's Pau Gasol's on top of Haslam because he averages more points than Haslam does. Because Gasol averages more points than Haslam. So as you can see right here, the order that you input it in is the order that it's going to sort the values by. But like right here we have age and points, and like we have say we want like the most points with the youngest age. Like we want to find like the young studs in the league, like the guys that are extremely young and playing at a really high level. So we're gonna have to do two different sorts, right? So like one has to be ascending and one has to be descending. Ascending for the age, and we want the points to be descending. So in order to do this, just gonna copy and paste. So we want age and points, right? And you leave the first argument the same, the age and points in a list, and now you add another list where this list is a binary list basically, and one means that it is ascending, and 0 means that it's descending, right? So 1 0, so we want the first argument is 1 and the first argument's age. So we want age to be ascending, and we want the second argument 0, second argument's points, and we want the points to be descending. Oops. Did I do wrong? Ascending. There we go. I forgot to set it to ascending because this takes more than one argument, so it goes like what you want to sort by, then the access, and then ascending in place, all these things. So you have to specify the argument. So now that I specified ascending, you could see that the youngest player was 19, and he averaged 21.2 points. And you could see there was a bunch of 19 years old that average less points because obviously we're sorting by youngest age with the highest points. So we're going, the age is the same, but they're each making less points, as you can see. So that's how you sort values on different columns, and that's how you change the like whether it's ascending or descending, even though you're grouping and you're sorting by two whole different columns. All right, so now say we want to alter the data, right? We have all these columns. Say we want to add a column, right? So adding a column is extremely easy. You literally just write the name of the column. So say we want country, so where they play. So we made df of country, and we're just gonna set it equal to the value that we want it to. Since the NBA is in America and it's American League, obviously all these guys, country is gonna be USA because that's all where they play. Make sure that's in string format. Now you see df, and you can see all the way to the right that we got this country right here. It's pretty cool. So now say we want to like do an aggregate of the functions. Say we want to create like an aggregate of like the points, the blocks, the steals, assists, and the rebounds. Like we want to add those together to see who had the most of those 5 numerical averages. So we're gonna create a total row. So we're gonna do df and make a total row. And we're gonna do totals. That makes more sense. And we're gonna do the data frame. So first, data frame.I location. And so first I'm just gonna type it out, and then I'll explain to you what's really going on here. All right, cool, it worked. All right. So first you do the data frame, and you create a new row in a new column called totals, and you set it equal to the I location of the 6th to 11th columns, and you sum it. So what's going on here is, remember, the I location, it takes 2 arguments for as much as that we have learned, right? So the first argument right here, x is going from 0 to 10. So the first argument is the rows argument, and then the second argument is obviously the columns argument, because now after you see me put in that second argument, it got the shortened to just those 5 columns, right? So what we did is, we want to sum up every single row, right? So we just left the row argument blank and just did this, just put that colon, meaning that we're talking about every single column. So it does not matter, we don't have to specify the columns. And then for the rows that for the columns that we want, we did 6 through 11. Why? Because we only want these right here, right? So we go 0, 1, 2, 3, 4, 5, 6. So that's where the point starts, at 6. Then 7, 8, 9, 10, and the rebounds ends at 10. But we do up to, but not including. So we have to do 11 to include those rebounds in. And then once we specify that, the I location, all we have to do is put dot sum and axis equal to 1. So meaning that we're going to sum all of these. We're going to sum all of these at I location columns 6 through 11. We're going to sum all those values by the horizontal axis. So we specify axis equal to 1. If you want to do it vertically, 0 would be the axis. But we're not doing it vertically. We're not summing anything up and down. We're summing left to right. All right? So we did that, and we called that function. And now if you go to df, you could see there's this totals right here. And if you add up 5.3 plus 0.2, that's 5.5 plus 5.5 plus 0.5 is 6, and then 6 plus 6.6 is 6.6, and then 6.6 plus 1.5 is 8.1. So clearly this totals columns works, and it goes right through all the people stats. So now, say, what if you want to drop a row and drop a column? Well, like, say we want to drop the country column, because I mean it's pretty useless. Everybody plays in USA, and we know that. So now, in order to do that, you just call the data frame name .drop, and you specify the columns that you want to drop. So you just do columns equal to whatever columns, and these are going to be in the list just in case you want to do more than one column. So we did df.drop columns, and perfect, we don't have the country column, so we're going to check that out. Df, we still have it here. Why is that? Well, that is because this function, the drop function, and literally every other function that we did basically does everything in place. So you're gonna have to override that original data frame with the data frame that drops country. So we do that, doesn't return anything. We check it out, and now country is officially gone from the data frame. And now say we want to move a column. We have this totals column over here all the way to the right, but we want to move it, let's say we want to move it to in front of the points. So in order to do that, you're gonna have to do a little bit of like intuition here. So if you remember from before, the df.columns, it gives you all these columns of a tuple, of a list inside of a tuple, right? So if we just cast list on this, we get df.column. And if you just cast list on df.columns, then we get all the columns, titles in a list. And we're going to set that equal to calls for columns, right? So now what we're going to do is we're going to overwrite the df data frame just by slicing through this calls list. So this is calls, right? So if I was to call calls of zero, I get the name. So what if I did df of calls of 0, right? So we work backwards. So first 0 with index inside calls. What is that? That's name, right? So then it's going to be df of name. And if you remember, all the way up here somewhere, we realized that you could just search through columns. You could search through columns just by putting that column title. So say we want just a name, right? And we got that, right? So back to the example. So we did calls of 0 is name, right? So we did df of calls of 0. So calls of 0 represents name. So we're essentially doing df of name, and we get the names, of course. So using that same exact intellect, we're going to override the df, and we're going to make the totals be right here, to the left of points and to the right of salary. So we're going to do df, and then df is going to be equal to that original df, but with the columns all placed around. So we're going to go 0 through 6. So we got the first 6 columns, right? 0, 1, 2, 3, 4, 5. You want up to salary, but we do 6 because it's up to but not including. So we calls from 0 to 6 plus we're going to do calls of 17, I believe. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this is the 17 column. And we're going to have to put this inside another list because since it's just one number, it's obvious that what this is going to return is just the header totals, and you cannot concatenate that totals string with this list right here representing name, height, weight, team, age, salary. So you would have to make this into a list of its own just by casting it within brackets. And then now we just do all the columns up to 17, but since it's up to but not included, we put 17 and essentially means 16. We click OK, we get nothing back, that's good. We type df now, and what you can see is this totals is no longer there. It's field goals attempted, and the totals is right in front of the points, and right next to the salary, exactly how we wanted. So now say really quickly that we want to label all players that are that have more than 25 points as good, and every other player that has less than 25 points as bad. So now you could pause the video and think of how you're going to do this. And I'll show you exactly how to do it right now. So first we got to create a column called good or bad, right? So we set that, and we're going to set it equal to bad, meaning that every player initially is going to set equal to bad. All right. And oh, you can just ignore this right here. And so now we do df, and you can see that we got a good or bad column, right? And they're all bad right now. And now we're going to change it so that if they average more than 25 points, they're going to be labeled as good. So obviously we're going to use a location function there. We're going to find the location of points that's more than or equal to 25. And to change, and so now we want to find every occasion where points is more than equal to 25. And in that occasion, we're going to change good or bad, the row. We're going to change that to bad. And we're going to change that to good. So what this is, we access the location of points, right? So df.location, and we want to find the location where the points column is more than equal to 25. And then after we do all that checking, right, we want to access the good or bad. And if the points are more than equal to 25, we're going to set good or bad equal to good. If these guys are all bad, let's say we want df trying to think who the first player was with above 20. You know what? Instead, I'm just gonna do. Oof, what is that? That is not good. Oh, I know what I did wrong, of course. df location is equal to. Man, I did a lot of mistakes here. There we go, perfect. And you could clearly see right here that LeBron James, he averages more than 25 points. He averaged 27.4, so now he's labeled as good. All these guys are labeled as bad because none of these guys average more than 25 points. So, yep, as you can see, that clearly worked. And now say, we're just gonna do really quick rejects. If you know how to do rejects, that's great. I personally, before I made this video, I had to learn more about rejects because I'm not too great with it. So, this example is not really necessary. If you don't know rejects, don't worry about it. You could always learn it on your own or just have a cheat sheet like I did and just look up like reject expressions. So what you're gonna do is gonna use a location function again. You're gonna access the name inside the column. You're gonna change that to string contains, like dot string dot contains, and inside here we're gonna enter the rejects expression. So we're gonna do starts with last name starts with P, and then the rest of the letters could be A through Z. It doesn't matter what the rest of the letters are, so long as it's just gonna start with the letter P, right? And we had to set the rejects argument equal to true because we are using rejects expressions here. And bang. Oh, I did rejects. And now you can see all these guys over here. The first name starts with P. PJ Tucker, Pascal Siakam, Patty Mills, Paul George, and etc. So that's how you do rejects expressions. And finally, we're gonna do just a really quick group by. Group by is just like you want to group it by a certain attribute. So obviously, grouping by name wouldn't really make sense. There's not two Paul Georges. There's not two Patrick Beverleys. Instead, say we want to group by teams, and we want to see the mean age, the mean salary, and all that. The mean point, something actually important for each team. So to do that, we're gonna do df.groupby, and we're gonna include what we want to group by in the parentheses. So we want to group by the team, and on these teams group by, what do we want? Say we want the mean, so you do dot mean. That is weird. Let me see what I'm doing wrong. Just give me 1 second. All right. I fixed it. I don't know exactly what I was doing wrong, but that's no problem. So we're gonna do that group by on the team. So we're gonna do df.group by whatever we want to group by team and what stats we want. So we group by the team because that makes sense. What else would we really group by? And we want the mean for each. So let's scroll down to my favorite team, the New York Knicks, and you could see that our average height was 79.9, average weight was 225, and let's say we scored an our teammates, our players scored an average of 9.3 points. Let's look at something even more important. Field goal percentage. That's a really good stat to look at to gauge a team. As a team, we shot 44.37%, so not too bad. And yeah, so this is a group by. You just use the data frame dot group by and what you want to group by, and then dot the function that you want. So say we want count, count is kind of pointless because that doesn't really make sense. But we do sum. So you could see that the Hawks scored 179.2 points. Well, the sum of their averages is 179.2 points. Sum of Lakers average is 155.5, and things like that. So yeah, that's pretty cool. And that's basically it for Pandas. I hope you guys enjoyed that part. I'll post all of this code online, so then you could just go through it and see what you missed, if you missed anything. Plus, since this is being recorded, obviously you could watch it more than once. And now we're going to do NumPy, so we're just going to import Alright, so we're going to do import NumPy as NP for NumPy, obviously. And we're going to create some arrays. So first, let's create a one-dimensional array. So if you look at X, you could see it's type array, 1, 2, 3, 4, 5, very simple, just like a list. We look at the type of this, we get a numpy.nd array. Now let's say we want to make a 2D array. So we got y equals np.array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as you can see, these are two lists within a list. And you can see it's two lists within a list. If you took like intro comp sci, you could realize that this each individual list, so this list right here is each individual list, you could see them as like rows essentially, and each index position you could see them as columns. So when I print out that array, you could see that this is all column 1 right here, the 1 and 6. Column 2 is 2 and 7, but then the rows goes by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how you make arrays. If you want to see the shape of your array, so you do x.shape, and you can see that the shape of x is 5, and there's a comma and a blank. That means 5 by nothing, because since it's a 1D array, it's one-dimensional and only has a row. It only has one row. That's 5. That has 5 elements. But if you look at y.shape, you could see that it's 2 by 5, meaning there's 2 rows by 5 columns, which is true, right? So we got that 1, 2, 3, 4, 5 row, 6, 7, 8, 9, 10 row, and then there's 5 of these columns. So that's pretty cool. If you want to check the total size, you do the array.size. You can see x is 5, y is 10 elements. So say if you want a specific element within the array, it's very simple to just like regular Python list. And a regular Python list you would do so in regular Python list, if I want the first element, I just do regular of 0, and I get the 0th index. So same thing, I do x of 0, and I get 1, because obviously 1 was the first element of the x. So now how do you access a 2D array, right? To do a 2D array is like, the way it takes an argument is it takes row, comma, column. So row, comma, column, like that, right? So say if I want y and I want the index, the y of 1, so the index 1, the row at index 1 is what I want, right? So since remember, it's row, column, always remember that, x by y, right? So if I do y of 1, I want the first row. Well, I want the second row technically, since it goes 0, 1. And as you could see, I got the second row. 6, 7, 8, 9, which happens to be an index 1. So now say if I want the number 7, right? So what would I do? First, obviously, I'll access the second row, and I want the second column as well. So it will be y of 1, comma 1, and I get the 7. Now say if I want, like obviously I could just get the rows by doing like y of 0, y of 1, since row is the first argument. But say if I don't care about the rows, so I'm gonna leave that empty, just like we did with that pandas part. We're gonna leave it empty. We're talking about every single row is included. We don't care about the rows, so we just put that colon, comma, and now say we want only the elements that are at column 2, right? So if we go to column 2, 0, 1, 2, you can see 3 and 8, and that's exactly what it gave us. It gave us the list of 3 and 8 in array form, which is really cool. Say if we don't care about the row, but we just care about the columns, and we want columns 2 through 5, then we got everything in its form as it originally was. So 3, 8, 4, 9, 5, 10. Very cool. If you want to change an element, it's just like a list. So if you want to change y of 1, 2, we'll just set that equal to, actually we'll do y 1, 1 since we know that's 7. Say we want that to be equal to 17. Just do that. We check out y. See y of 1, 1, 0, 1, 0, 1, 17. Instead of the 7 that it originally was. So that's how you override these values just like you would in a list. So now say if you want to make a new list, there's 2 lists, 0s and 1s, that it could already make for you. NumPy could already make for you. So we do np.zeros, and the first argument is going to be how many zeros do you want, and the second argument is going to be type, and we want say. So say we don't specify a type, so we get zeros all floats. But say if we want ints, so you want 0 int, and you can see we get 10 zeros in array in integer form. The other one is np.ones, so this creates ones obviously. So now we want 10 ones. We got 10 float ones, and say we want integer form, we got 10 integer ones. So 2 very quick functions to make these lists. Obviously these lists are made, these arrays are made like just in time. So if you want it to be stored to memory, you got to actually set it to a variable. So say if you want to make an array of your own number, right? So now you do the numpy.full, meaning you want, like, I don't know what full actually stands for, but just use the full if you want to specify a specific number. So say you full, and I want the number, let's say I want the number 7. So the first argument is the size of the array you want, right? So say I want a 2x4 array, so a 2-dimensional array, and it's 2x4. So first argument is going to be a list, and it's going to be 2x4. Second argument is going to be the number that you want to populate it with. I want 7s. And the third argument is going to be the type, and I want integers. So now you can see I got 2 rows by 4 columns integer array full of 7s. Now say if I want, this is a really useful function by the way, say if I want to create an array with random numbers. So if you know the math library in Python, the math.random generates a number from 0 inclusive to 1 exclusive. This does the same thing. So we're going to do np.random.rand, and you just specify like the size of the array that you want it to be. So since the number's already set, so say I want a 10 by 10 array. And I got a 10 by 10 array of random numbers randomly generated. So we got all these decimals, right? Very useful function. And now say if we want full numbers instead, so we do np.random.randint rather than just rand. And this has a lot more arguments because obviously you want to provide what numbers it wants to be between. So the first argument is the start, and that's inclusive. So we want to start at number 0. Second number is exclusive. So we want this list to be populated with random numbers from 0 to 100. So we're going to do 0, 101, since it's up to but not including. So it'll be numbers up from 0 to 100. And then the third argument is going to be parentheses and the size you want. So we want 10 by 10 again. And that's it. So now we got 10 by 10 array of numbers 0 through 101. And what I noticed off the bat is there's 2 zeros, which is pretty cool, I guess, because, I mean, there's a 1 in 100 chance, and one of them is 0. Well, I mean, there's 100 numbers here, so I guess it's not that big of a deal. Anyways, so really quick example, I'm just copying arrays. So if you were to do a list, right, you do x equals 1 to 3, you set y equal to x, you change y of 0, and you change it to 7, and y is changed, obviously, and x is also changed, right? Same thing goes with numpy arrays, so we can do x is equal to np.array, 5. We're going to set y equal to x. We see y is this array. We're going to change y of 3. We're going to change it to, let's say, 14. And you check out y is 1, 2, 3, 14, 5. We check out x, it's 1, 2, 3, 14, 5. So if you want to make a copy of an array, instead of just setting it equal to each other, you're gonna do whatever you want to set it, like whatever you want to whatever array you want to copy. So you can make a new variable. We made a new variable y, and we're going to set it equal to x dot copy. So it's a copy of the list. So now y is this, x is this, but if I change y of 0 to 100, you see y changed, but look at x, still 1, 2, 3, 4, 5. So simple as that. And now we're just going to do some really quick like mathematical operations. I know I'm a little bit over the time, so we'll do this kind of quick. So say if I set x equal to numpy array, I mean, x is already 1, 2, 3, 4, 5, so we're just going to leave it, right? I'm going to set y equal to x dot copy like we did before. So now we got 2 of the same exact arrays, just represented by different variables. The thing is, we could do we could add and multiply these arrays, and like if you were to, so say if I, in just like regular Python, if I added 1, 2, 3 plus 4, 5, 6, it won't actually add the numbers inside. It'll just essentially concatenate the array, the list into one. But say if I did y plus x, and these are numpy arrays, remember? We get 2, 4, 6, 8, 10. Why? Because it adds every single number with each other. So 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6, and so on. So you could do that same exact thing with more than just addition. So you could do subtraction. Obviously, these are all going to be zeros since they're the same numbers. Or if you want x times y. You got 1, 4, 9, 16, and 25. You could also do x divided by y. So obviously all going to be 1s because of the fact that it's the same number. You could also do x to the power of y. So these are all numbers to the power of themselves, right? Also, if you want to do operations on just single array, you could do like the sum of x if you want. You can do x dot sum. If you want the sum of y, you do y dot sum. It's the same array, remember? So it's going to be same thing. You could also do like the mean, x dot mean, things like that, right? So 3.0. Things like that, just very simple operations that you could obviously think that you're going to use. Okay. So now say we have this array like we did before. Say we have this array. Y, that's a 2D array, right? So say we want the biggest number. So we do y dot max. Not y dot max. np dot max, and you pass in the array. So that finds the max number in the whole entire array. And it's 10, obviously. You do the minimum. And you get 1. Simple as that. Now say if you want like the max, but you want only the max among like the columns. Alright? So you do np to max and you pass in that y. And you're gonna specify 1. So then this 1 is gonna be the columns. So you could find the max, or you could find the max column, which is gonna be obviously the 5 and 10 column. Which is obviously gonna be the 5 and 10 column, because 5 plus 10 is 15. So it's gonna be this column right here, and it returns it. And now say if I did max 0, meaning like the max among the rows, obviously it's gonna choose the second row, 6, 7, 8, 9, 10, because that's obviously bigger. And now say if we have this 2 by 2 and 3 by 3 array. Right? We have this 3 by 3 array. So we look at it and it's 3 by 3. What if we want to reshape it? Right now it's 2 rows by 3 columns. What if you want to change it to 3 rows by 2 columns? Well, you could do something simple as x.reshape, and it's going to be rows, columns. So now we want 3 rows, 2 columns instead. And look at that. It's completely reshaped. If I want six rows and 1 column, I could do that, 6 and 1. And yeah, so that's about it for our very short and sweet introduction to NumPy. And that's actually it with the whole entire lecture. Let me just really quickly stop sharing. Turn on my video. All right, so thank you guys so much for watching this video and making it to the end. Once again, I'd just like to reiterate that what we learned today is not everything that you could do with Pandas. It's not everything that you could do with NumPy. It's just the basics. And it's a very in-depth version of the basics. I mean, we went over everything in Pandas that I've been using and what I really thought was important. There's more advanced functions too that I'm sure you're gonna learn down the line somewhere. But for now, you guys should really practice the functions that were taught because they're all extremely important and they're pretty much the main ones. So yeah, I will be having an office hours on Tuesday. The exact date being Tuesday not Tuesday, Thursday the 4th. So if you have any questions, you could hold it till then. Or you could email me at jaypat0885@gmail.com. Other than that, that's about it. Hope you guys enjoyed, and thank you.